So this is lesson 4 in Algebra 1, the review of arithmetic, and I'm expecting you to take notes over 4a, b, c, and d, and it's just a bunch of theory reminding you, reviewing what real numbers are, natural and counting numbers, and the difference between a number and a numeral, as well as a number line. So we're going to jump to section 4e, multiplication and division of fractions. So remember, when you are multiplying fractions, like 3/5 times, and I'm going to use a dot for a times sign, because when we get into algebra and we start using the letter x to show the unknown quantity, sometimes it looks like a multiplication sign, so we're going to use a dot to show a times. So let me put a fraction like that there. And the way you multiply fractions is you multiply the numerators and you multiply the denominators, and you get an answer there. Now remember, when you get an answer, if that answer is improper, meaning the top number is greater than the bottom number, you have to divide the bottom number into the top number. And you get 1 times 15, and then we get 6, and it's 1 6/15 is the answer that you get when you're writing it in an improper method. Most of the time, I am going to be happy with improper fractions. I'm not going to be happy with mixed numbers, but that's just a reminder of how you do it. And then once you get 1 6/15, this can be reduced because 3 goes into 15 and it also goes into 6. 3 goes into 6 twice, and 3 goes into 15 5 times. So actually 1 2/5 is your answer. Or if you reduce this improper fraction here, both 3 goes into 15 and 21. 3 goes into 21 7 times. 3 goes into 15 5 times. And you get 7/5. So these are both the same answer. It's just this one is improper and this one is a mixed number. Now, division of fractions, you've done that before also. When you have a division of something like this, the second number, you flip upside down and multiply. And you get 32 over 45, and then you reduce it. You find out what is common to both 32 and 45, and if possible, you go ahead and reduce that down. And in this case, there is no number that goes into 32 and 45 evenly, so we are done, and that is your answer. But in order to not have to worry about reducing, I cancel actually before I even multiply. So let's go ahead and look at this one again. And what I do is I write my 4 as 2 times 2, product of primes. And I write my 8. And then I write my 15 as 3 times 5. And I see if there is anything in the top, 2, 2, 2, 2, 2, that can cancel with anything on the bottom. And at this point, I don't have anything common with my top or my bottom, so I know that this ends up being my final answer. But if I do have a problem that I'm able to cancel, so let's say, for example, I have 3/5 times 5/6 times 21 over 23. So I write those as my product of primes. 3 and 5 are already primes, so those won't break down. But my 6 can break down to 2 times 3. My 21 can break down to 7 times 3. And my 23 cannot break down. Well, in this case, I have a 3 here and a 3 here that I can cancel, and a 5 and a 5 I can cancel. So now I get 7 times 3 is 21, because that's all that's left that wasn't canceled. and then I have a 2 and a 23, which is 46. So I know that that cannot be reduced because I already reduced it here before I actually multiplied. So what if I have something like 2.5, and I want to multiply it by 5 1/3? Alright, first step, we're going to change both of these to improper fractions. So 2.5 is the same as 2 times 2, add the 1. 2 times 2 is 4, plus 1 is 5, and then we put it over the denominator. And 5/3 is 5 times 3 is 15. We have a 16 over 3. And we multiply. And I'm going to go ahead and write this as the product of primes. 5 and 2 are already prime, 3 is a prime, but 16 can be reduced down to 2 times 2 times 2 times 2, which allows me to cancel that 2 with that 2. So that means when I multiply my numerators, so that is going to be 40, and I have my denominator, which is just a 3, I know that that cannot be reduced. It's 40 over 3. And because I started out with mixed numbers, my answer has to be a mixed number. So I go ahead and divide 3 into 40. And I get 1, 0, 3, 9, 1, 13 and 1/3 then for my answer, because I want to put it back in mixed number format. Now if you remember, when we divide again, it's the same as inverting and multiplying. So we have that divided by 2 and 1/6. So what we're going to do is we're going to change them to improper fractions first. 37 over 3, and I'll change this to 13 over 6. Now I will invert and multiply. You invert and multiply after you make them improper. Alright, so I've got 37, that is a prime number, 3. 6 is not a prime number, it's 2 times 3 over 13, and that allows me to cancel this 3 with this 3. And that gives me 74 over 13. And then I can change that to a mixed number by dividing 13 into 74. And in this case I get 5 and 9 over 13 for my answer. Now the only reason you changed an improper fraction into a mixed number is because we started with mixed numbers. And so therefore we're going to go back there. Alright, 4F, symbols and equality, of equality and inequality. If we are saying that two numbers are equal to each other, such as 5 is equal to 5, we put an equal sign there. If we say 5 is equal to 4, we know that's not true, so we put a line like that saying they're not equal. So if I say 5 plus 2 equals 7, the quantity over here and the quantity over here are the same. But if I say 5 plus 2 equals 11, I put a line through there showing that that is not a true statement. The equal sign means it is a true statement. The line through the equal sign means it's not a true statement. And just to remind you about multiplication, we can write 4 times 3 this way, this way, this way, or this way. Those are all the different options to write 4 times 3. We will not be using this hardly ever anymore. In fact, very rarely will we use in that one. We usually use this one right here. So just get used to being able to recognize multiplication that way. The number 0 has a unique multiplicative property. The book says the product of any number and the number 0 is the number 0. So anytime you multiply 4 times 0, you always get 0. Whenever you multiply x times 0, you get 0. Anything times 0, you're going to end up getting 0 for the answer. In 4H, they start reviewing decimals. Decimals can make some major mistakes with decimals. The key thing when you're adding and subtracting decimals is to line up the decimal points vertically. And if you look about midway down on page 19 where they have 1.005 added to 300.012, notice the thing that is very important there is the decimals are lined up. Doesn't matter where the rest of the numbers are, the decimals are lined up. They do that with example 4.1, and notice in 4.2 when they subtract, they do the same thing. The decimals are lined up. Now when you multiply decimals, you don't have to line those up. It doesn't really matter if they're lined up or not. In fact, you really should not worry about lining those up. And I'm sure you remember when you multiply decimals, you just ignore the decimals completely. And you end up with 2436. And then we multiply 6 times 1 is 6, 0 times 1 is 0, 4 times 1 is 4. And then we do 6 times 0 is 0, 0 times 0 is 0, 4 times 0 is 0. And then we add all these up, 6, 9, 4, 6, 0. And our decimal place is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So our decimal place goes right there. So we get 0.06496 for our answer. And if you remember, division is very similar. You pretty much ignore the decimal in the number underneath the box there. And if you were to divide this way, you would just do your division and your decimal place goes up. But if you have both your divisor and dividend being decimals, so for example you have 0.03 and you're dividing that into 603.9, then we move our decimal over there 2 places, which means we have to move this decimal over 2 places. So our decimal is there, so then we carry it up to right there. And we just divide like we normally do, and the decimal's already where it needs to go.